All right, guys, so book outs, paper outs, no vocab today, so go ahead, name, date, period on your book, assignment number, label your paper with the assignment itself, the problems. Bless you. Okay, so we are going to continue with the idea of a circle. We're dealing with still the figure of a circle. All right, yesterday, just a quick little review there. Yesterday, when we dealt with the circle, we dealt with the length around the outside of it, right? The perimeter, or what we call the circumference, okay? And when you deal with circumference, you're dealing with just measuring a straight line. Well, actually, in this case, right, it wasn't straight. That's why it was called a circumference. Today, though, we're going to keep the same figure, like I said, but what we're going to do is we're going to actually solve for the amount of space that fills up the inside of the circle. Okay, and that is what area is. Now, just a little FYI, when you're dealing with area, what you're really dealing with, no matter if it's a circle or what kind of figure it is, what you're really dealing with is you're actually truly, because we can't measure it with any kind of a line or a ruler or even a string like yesterday, right? What we need to do is we actually need it to measure it with some kind of two-dimensional tool, and in that case, they are squares that we measure with. So when you're finding area, what you're ultimately doing is finding out how many squares fit inside that figure. Okay, now you can't just draw the squares and count them because there's lots of little parts, especially on a circle, there's parts of squares. So of course, like we talked about yesterday, in the history of math, there was someone that actually found a pretty accurate way to deal with finding the actual area. So this is what we're doing today. So when we go ahead and go about doing that, let's go ahead and let's start with book page 565, okay, number 1. And on number 1, all I want is I just want you to, you don't even have to write this down. It isn't, it's not even part of your homework, right? I just want you to watch, okay? Because I want to show you just, I do this, and every time I do one of these problems, you're like, oh, it's so hard. Oh, it's so many steps. And okay, and I want to show you just how easy it is. All right? So, on number 1, on page 565, the directions say find the area of each circle round to the nearest tenth. All right, so what we have is they have a diagram that's drawn. It looks kind of like this. And just my sketching here, it look like this. Okay? Now what that is that's a circle with a radius of 7 meters. Now when you find the area of the circle to find out how many squares would actually fit in there, in this case square meters, I'm going to go ahead and use the formula. Now, formulas are going to be guides to be able to help guide us to the answer, okay? The letters will always stand for, in this case, a symbol will always stand for something, all right? And so we need to be careful with that. But the bottom line is in geometry, you need to make sure you're using the right formula because there's different formulas for any different type of figure that you're dealing with, okay? 2-dimensional, 3-dimensional, whatever it is. So here's what we're going to do. Just to show you, let me go ahead and show you how to solve this and how easy it is. So what I do is pi, it always remains the same. It's 3.14. The radius in this case is 7. And so we have 7 squared. Now, according to this, according to our order of operations, like that pink poster up in our room, okay, after parentheses, meaning solving what's in the parentheses, I do exponents. So remember, this isn't 7 times 2, it's 7 times 7, which gives us 49. In this case, I bring my 3.14 down, okay, and I go ahead and I want to make sure I use my calculator. 3.14 times 49 equals, and it comes out to, the area of this thing is 153 and 86 hundredths. Now on that problem, it does say round to the nearest tenth. So there's the tenths. 6 makes the 8 go up, right? So 153 and 9 tenths And I don't want to forget my units. But ladies and gentlemen, it's not meters. I need to show that I'm finding the area. And I show that by showing square meters. And that's our final answer. Okay? So that's what we're doing today. All right? And I'll walk you guys step by step, but you'll find that today's steps are very much like yesterday's steps. All right? So with that said, let's go ahead and do one together. So let's take a look at page 565 and let's check out problem number 5. Okay, so problem number 5, it doesn't show us a diagram. It actually gives us a description. It says there's a diameter, and of course they're referring to a circle, and it is 10 5/10 centimeters. So here we go. Step 1 is, let's go ahead and write down our formula to guide us. Its area of a circle is pi r squared. So I'm going to go ahead and write it down. Step 2, very much like yesterday, plug in the numbers. And very much like yesterday, I need to be careful. When I plug in the numbers, pi is always 3.14. However, the radius, I do not plug that in. Be very careful. Some people just get in a rush and plug any old number in. You got to plug in the correct number. That's where the r comes from. That's why I said it helps guide us. That is the radius. If you remember right, the radius is half the diameter. So a lot of them you can do it mentally. Some of you probably can even do this one mentally. We have 10 5/10 divided by 2, and it gives me 5 25/100. Now do not forget to bring down your exponent of a 2. Now once we've plugged our numbers in, now we simplify. We always start, in this case, with the exponent. So 5.25 times 5.25 equals, and I get a pretty ugly number here, is 27.5625. But that's the nice part about using a calculator. I can keep it like that. I record it down on a paper. And now I continue to simplify. We're not done yet, so I'm going to multiply those two together. That big one's already in my calculator, so I hit the multiplication sign. 3.14 equals, and one that's equally as ugly, 86 and what is that? 54,625 hundred thousandths. That's how you say that. All right, so so now we're going to call this step star because on tonight's homework you're going to notice that it's not going to happen every time, but I need a round. And I need to check if this is one of those that I should round on. And it does say round to the nearest tenth. So just like the last one I did that I showed you guys, there's the tenths. The 4 makes us 5 stay the same. So we end up with 86 5/10. And now comes what we can call step 4. Put your units on. Be very careful on your units, guys. Okay, you will miss it if you put the wrong units. And the wrong units mean that if you don't put the square on there, that would be saying that you're finding something like the circumference or a straight line. And when in reality we're finding out using squares, right? How many squares fit in there? So 86 5/10 square centimeters. All right, questions?
On our homework, do you want us to use 3.14 or the pi symbol on our calculator?
Okay, so I'm actually pretty lenient on it as I'm looking at the key in the book. They give us 86.6 square centimeters, so that tells me that they're using the pi key whenever they built your guys' key. So, and I made our PowerPoint slides off of the book key. So, just realize that I'm flexible on it. I'm okay either way. I believe, though, that the test, when you guys get to your test, that everything is used by 3.14. So you might want to keep that in mind, too. Okay. All right, guys, any other questions? All right, go ahead and try this one out. Here we go. Problem number 8. Problem number 8 on 565. Go. Okay, anyone need more time? Okay. A few more seconds. If you guys are, for those of you that are done, you can go ahead and continue on problems that are very similar, just your basic problems. We're not sharing quite yet. During this time, guys, make sure you're using your notes. Okay, 30 seconds. Go ahead, turn to your neighbor and share. Go.
I got 50.2 centimeters squared.
Oh, I got 50.
All right, so for number 8, right, you guys had a circle that looked like this. And again, same directions, right? They want us to find the area round to the nearest tenth. So, following the steps, you should have written area equals pi r squared. Second step, we're going to plug in 3.14 for pi. Our radius, they give us the radius here. We don't have to split anything in half. It's already the radius, so I plug in my 4 for 4 centimeters. Don't forget my exponent. Okay, so if I continue, 4 squared is 16. So what I end up with is 3 1400ths times 16. So 3 1400ths times 16 equals, I end up with an area of 50 2400ths. However, it says round to the nearest tenth. So 4 makes the 2 stay the same. So we end up with 50 2/10. And I need to make sure my units are in centimeters. It's square centimeters. And if you use the pi key, it's 50 3/10 square centimeters. Okay, questions on that one? Okay. All right, let me go ahead and I want to show you a different type of problem. Let's stay on 565. Let's take a look at problem number 6. So number 6, let's close read that word problem. It says a motion detector at the of a building can detect motion outside within a of 20 feet as shown. Within what area can it detect motion? Round to the nearest tenth. Okay, so if you guys see, right, they give you a little picture, and that picture is, a picture, and it shows like a kind of the sensor kind of bubble, right, which is just, of course, what we're looking at here. And so what we have is we have something that looks like that. Okay, no, it is not Pac-Man. All right. So what they show you is they give you this little arrow, right? It shows 20 feet. Okay, now listen carefully. On a problem like this, which is obviously part of a circle, okay, there's really only one extra step to this. So here's what we're going to do. Okay, and there's a number of different ways we can do this, but here's what I'm going to do. Step 1 is I'm going to find the area of a full circle. And what that means is I'm going to use the info they give us and pretend that this isn't a part of a circle, it's a whole circle. Okay? So whenever I do this, I have my diagram. I'm going to go ahead and I'm just going to go through the steps we just went through. A equals pi r squared. plug in our numbers, 3.14 for pi. The radius is right there. It's 20 feet. That's the radius of that circle. It's that little arrow they drew. 20 squared. So 20 squared, of course, is 4 with 2 zeros, right? 400 times 3.14. Go ahead and grab the calculator. 3 and 1400ths times 400 equals 1,256. Now, here's what I'm going to do. Step 2. I am not, however, finding the area to a full circle. What part of a circle, guys, is this? It's 3/4 of a circle. So here's what I'm going to do. I am going to find the part. In this case, I'm going to multiply by 3/4. Now, because we have a calculator and we're using 3.14, I can multiply that by 3/4, which would be fantastic. Or I'm going to take my 1,256 and multiply by 75 hundredths. Right? It's the decimal equivalency of 3/4. So take that, multiply by 0.75 equals, and I get 942. And now, of course, we can call step star is round if we need to. Well, in the way I did, there is no round being needed. But there is a step 3, and that is, of course, get your units on there. So it's talking about feet. So it's 942 square feet that motion detector covers off of the corner of that house. If you use the pi button and you want to double check yours, it rounds out to 942 and 5/10 square feet, 0.5 square feet. Okay? So just that extra part of find the whole area of the whole circle and then multiply by whatever part you're looking for. Okay, if it's 3/4, 1/4, 1/2, whatever it is. Okay? All right. One I want you guys to try out is problem number 18. 18. All right, go. Okay, how many of you need more time? Okay. All right. Anyone still need more time? Okay. A few more seconds, and then I'm going to let you guys share. Okay, 30 seconds. Go and turn to your neighbor and share. Go.
I got 3,215.4 centimeters squared.
On this one, why did he tell me that was 175?
Because it's 3/4, which is how much that circle is.
All right, here we go. All right, so for number 18, it says each shelf of a shelving unit is a quarter circle with a radius of 32 centimeters. What's the area of each shelf round to the nearest tenth? So what we have is we have a shelf. I've actually installed a couple of these in my own house. It's one of those little corner shelves, and they kind of look like this. You can put like little things on it. One of ours is a tool. The other one has some Legos for my daughter, but it goes right in the corner of the wall. Okay, and bottom line is like it's describing is that realistically it is a quarter of a circle. Okay, now it does say that it has a radius of 32 centimeters. So there you go, 32 centimeters. So here we go. Bless you. I'm going to go ahead, solve for the area of the whole circle first. So pi r squared. Pi, I'm going to plug in 3.14. The radius is 32 squared. I am then going to take this here. 32 squared is 32 times 32 equals 1,024. Bring down my 3 and 1400ths. Now I multiply 1,024 with 3 and 1400ths. 3.14 equals, and I get the area of a full circle is 3,215 and 3600ths. Now don't forget, we're not dealing with a full circle, right? We're dealing with 1/4 of a circle. So that's my next step. I'm going to go ahead and multiply this by 1/4. Now what obviously I can do instead is multiply by 2500ths. So this big number is already in my calculator. I'm going to go ahead and multiply by 0.25 equals, and I get 803 and 8400ths. I need to check my rounding part. Let me reread it here. Round to the nearest tenth. So wants me to round right here. 4 makes the 8 stay the same. 803 and 8/10, and now my units are in centimeters. So it is square centimeters. Pi key, if you used it, it's actually 804 and 2/10 square centimeters. It's a little different. Okay, questions? Okay. All right, and then the last type of problem. I'll flip it over to the back side. On page 565, let's take a look at problem number 7. Let's close read this word problem. Here we go. May is making donuts. Woohoo! First she cuts out a circle of dough with a diameter of 8 centimeters. Then she cuts a hole in the middle with a diameter of 3 centimeters. What's the area of the donut? Round to the nearest tenth. Okay. Now that is, I kind of want to do this with you because some of you guys might not be able to visualize that, but here's what they're saying. She had this bit, and this is step one. Let's draw a diagram. Okay, diagrams, guys, really help. We have big piece of dough. Doesn't talk about it blowing up or anything, or expanding when you bake it or anything, or deep fry it, but or shrinking even. But I don't think they're worried about that. It says she cuts out a circle of dough with a diameter of 8 centimeters. 8 centimeters. Then it says she cuts a hole in the middle with a diameter of 3 centimeters. So there's this hole in the middle, and that hole put a different diameter here. That one is 3 centimeters. What's the area of the top of the donut? What they're really asking is, of course, what is this right here? Okay. So, here's what we're going to do. Step one, we're going to find the area of the whole donut. Or in this particular case, we can put of the dough. So here we go. Remember, this is the dough here, and it originally was 8 centimeters in diameter. So here we go. Area equals pi r squared. I'm going to go ahead, plug in pi, 3.14. My radius, ladies and gentlemen, is not 8 centimeters. I have to be careful. It's half of that. That's the diameter. The radius is 4 centimeters squared. When I simplify, 4 squared is 16 times 3.14. I'm going to go ahead and say 16 times 3.14 equals 50 and 24 hundredths. Now, it does say round to the nearest tenth, but here's what I'm going to do. I'm going to leave it like this for now. I want to round the least amount possible. Now, here's what's going to happen. She then cuts out a little circle in the middle. Now, first of all, let's talk about this strategy here. If you think about in mathematics, when you cut something out, what kind of operation is that?
Subtraction.
It's subtraction. She's subtracting a part out. But before we actually subtract, let's find out how big that is. So that's actually what step 2 is find the area of the smaller piece. So this is still a circle, so it's still pi r squared. Okay. And let me double check to make sure it says middle with a yeah, both of them are diameter, so this is a diameter of 3. So pi is 3.14. The radius isn't 3, it's 1.5 or 1.5. So plug that in. So now I simplify by plugging in 1.5 squared and I get 2 and 25 hundredths. And then I'm going to go ahead and multiply these two. 3.14 and I get 7.065. Okay. So now what you guys, now we're going to go ahead and put in effect what you guys just said a bit ago, and that is I'm going to take the area of the whole thing, and we said she's cutting out. So you got, just like you guys said, I'm going to subtract, line up my decimals. Now I could do it that way, or of course if you have a calculator, right? 50.240 minus 7.065 equals, and here's what I get, 43.175, 175 thousandths. And now it does say round to the nearest tenth. So I look at the 7 here. 7 makes the 1 go up. And this, of course, is what we've been calling step star, right? It's a little reminder. And we get 43 and 2/10. And then on this bigger problem, here comes step 4, and that is put your units on there. So it is talking about centimeters, so it is square centimeters. And that is our final answer. Okay, questions? All right. So some extra type of problems for area of circle.